All right, new topic is acceleration. So we've done position and we've done velocity. Acceleration is just telling us how much change there is in the velocity. It's the change in velocity. So if p of t gives the position of an object at time t, then p prime of t gives us the velocity. So we knew that already. The second derivative gives us the acceleration. So if you have v of t, that's the same thing as the change in position or the derivative of position. And if you have acceleration, that's the same thing as the derivative of velocity. It's also the second derivative of position. And the units are going to be units of velocity divided by units of time. Cool. So number 5, a ball is thrown straight up into the air with an initial velocity of 100 feet per second from the top of the tower. Its position function is given by negative 16 t squared plus 100 t plus 150. Find the velocity function. Okay, so I need the derivative of position. So that's going to be f prime of t. So that would be negative 16 times 2 t to the first power. The derivative of 100t is just 100. And derivative of 150 is just 0. So negative 32t plus 100. It's kind of familiar looking. Then acceleration, that's going to be the second derivative, which is, it's good that we have the first derivative. So derivative of negative 32t is just negative 32. And then derivative of 100 is 0. So if I want the initial position, that means t equals 0. And I want position, so I will do f of 0. So that's negative 16, 0 squared plus 100 times 0 plus 150. So 150. I want to check with units here. Let's see. Feet. Okay, yeah, it's feet per second. Well, it's actually, this one's position, so it's just 150 feet. What is the initial velocity? So initial meaning t equals 0, velocity meaning the derivative. So that's f prime of 0. So negative 32 times 0 plus 100. So that will be 100. And we just talked about how to do the units of velocity, and that's the units of position divided by units of time, which was seconds. So 100 feet per second. So is it going up or down? So I like to read the problem again. A ball is thrown straight up into the air with an initial velocity of 100 feet per second from the top of a tower. Okay, so I didn't need to do the math here. Its position function is negative 16t squared plus 100t plus 150. So initially it's going up. It was thrown straight up into the air. So initially up. When does the ball reach a height of 100 feet? Okay, so its initial height is 150 feet. So actually this picture over here is very helpful. I did not make this graphic. I think I've said before that this is not my note set. Well, it kind of is. I have like made it my own font and updated a couple of things, but this picture I didn't do. And it is very helpful in this problem because I know that at 150 feet, that's where I'm starting. So if I want to know when the ball reaches 100 feet, it's going up at first and it'll make a little peak and then it'll go back down. So I'm looking for like right in here somewhere. So it will only happen once that it gets to a height of 100 feet. So we need when, so position, so negative 16t squared plus 100t. Whoa, my handwriting became horrible. Okay, let's try that again. Minus 16t squared plus 100t plus 150. Oof. And I'm setting that equal to 100. So just to explain why I'm setting it equal to 100, I want to know when the ball reaches a height of 100 feet. So it says height of 100 feet. That's like saying when the height equation equals 100. And then if I solve that, I get a t, so that tells me when that happens. So I'll start by, oh, this is a quadratic. So hopefully you're kind of up to date with your quadratics. If I want to solve a quadratic, I will subtract to get 0 on one side. So I'll subtract to get 0. That gives me minus 16t squared plus 100t. 150 minus 100 is just 50. That equals 0. Now I am going to put this into the quadratic. I have an A, a B, and a C. So I'm going to do the quadratic equation over here. So quadratic says t equals negative b, so negative 100, plus or minus the square root of b squared, so 100, minus 4 times a times c, which is 50, all over 2 times a. So I just want to pause right here. If you are not comfortable doing a quadratic equation like I'm doing right here, this is something you'd want to post on the discussion board and like talk about. It's a problem that hopefully you've seen before, but it can be tough, and it is something that I am assuming you know how to do. So if you don't, let me know so we can work on it. So all of that needs to go in a calculator, and if you do that, you get 2 answers. Roughly negative 0.47, and this is seconds, right, because we solved for t, and 6.71. It doesn't make sense to have a negative time, but if you think about it, this graph really helps. If you could go back in time, the ball would have reached 100 feet, negative 4.7 seconds before the ball was thrown. Like if it followed the same trajectory, I guess is how we're going to think about that. So I think the correct answer is 6.71 seconds. That one's kind of tough. So if you're struggling with quadratic equation stuff, let me know. If you have another question about it, also ask that. But yeah, ask questions. It's a good thing. So the next question is, what is the height at t equals 5 seconds? Well, that one is a lot easier. That I'm just going to plug it in. So f of 5, which is negative 16 5 squared plus, let's see, was it 100t plus 100 times 5 plus 150. That I will be putting into a calculator, and that's 250 feet. what is the velocity at 5 seconds? So velocity, that tells me I want f prime. 5 seconds, I'm plugging in 5 for t. So that would be negative 32 times 5 plus 100. Let me make sure that's right. What was the velocity? Yeah, negative 32t plus 100. So calculating that, that's minus 60 feet a second. Is the ball rising up or falling down then? So the negative tells me it's falling down. Cool. So I think that's the last question. Oh, no, there's more. Okay, what is the acceleration at 2 seconds and then at 5 seconds? So I'll have to go figure out what our acceleration equation is. Okay, find the acceleration function. Okay, the acceleration function is constant. That's just negative 32. But we need units. Acceleration is units of velocity divided by units of time. So putting all of that together, doesn't matter what time, always it's negative 32 and then feet a second, that's units of velocity, over seconds, which another way to say that is negative 32 feet per second squared because of fractions. When does it have a velocity of 0? So when tells me I want t, I want to find what t is, and velocity, that tells me I want the derivative, so f prime, I need to find t, and it says the velocity is 0, so I need f prime of t equals 0. F prime of t equals 0. So I can't remember what f prime of t was, but I did do it. F prime of t is negative 32t plus 100. Negative 32t. Okay, so I will add 32, well actually let's start solving up here so we have space. So I'm going to start by adding 32t to the other side. 32t equals 100. Divide by 32t, or just 32. T equals 100 divided by 32. Calculator time. 100 divided by 32, that's 3.125. So at 3.125 seconds, the velocity is 0. And I want to know the height at that time. So f of 3.125, that's that whole equation, which I think I should have memorized by now, but I don't. Negative 16t squared plus 100t plus 150. So negative 16, 3.125 squared plus 100 times 3.125 plus 150. I should double check that I wrote that down right. It's negative 16, 100, 150. Okay, bingo, I did write that down right. So last thing to do is just plug that into a calculator. So I'm going to use my on-screen one because my phone just died. So negative 16, 3.25 Okay, so I get 156.25, and then 100 times 3.125. That's going to be 312.5 plus 150. Okay. So 156.25 plus, oh, and I bet that's a negative 156. Yeah, it totally is. So negative 156.25 plus 312.5. 156, sorry, I'm having some calculator issues. Plus 312.5 plus 150. Okay, I get 306.25, and that's feet. Cool. When does it, okay, so if it has a velocity of 0, that means it's not going up or going down. So I think this is the highest point. So next question, when does the ball hit the ground? So I've actually done a couple of these, and I think, let's see, yeah, this is the end. Yeah, this is the end. So instead of solving these ones, I think we've gotten plenty of practice. I'll tell you how I would set it up. When does the ball hit the ground? So hitting the ground, that means that the height is 0. So f of t equals 0. And if I solved that, I would be getting a t, which is a when. So I'd solve that equation. So for this next one, how fast? Fast is a speed thing. So I'm looking for an f prime of t. It's like involved somehow. How fast is the ball going when it hits the ground? So hits the ground, that is an f of t thing. F of t equals 0. So to solve this problem, the first thing I would do, so step 1, is solve f of t equals 0. So if I did that, I would know when the ball hits the ground. And then step 2, I would plug my answer into f prime of t, and I would be done. If you'd like more examples, let me know. I do feel like this is kind of a tough section. One thing to know is sometimes during winter term, the on-campus courses don't make it to 1.8 before the test. So it's possible that the test we'll do will only cover all the way to section 1.7, and then this section will end up on the next test. I won't know probably until Tuesday of week 3, and I'll let you know then so that you can study appropriately. Either way though, you will need to do this section, the homework, before week 4, but I do think it does relieve a little bit of the burden of being tested on if we know. Either way, I'll let you know soon, and best of luck on the test. I hope that you go into it feeling comfortable and confident.